In this video, we apply the relationship between an angle at the center and an angle at the circumference. This angle relationship can appear in different forms, so it's important to understand how these angles are made and how they're related, so we can apply the relationship to solve circle geometry problems. The angle at the center is the angle formed between two radii. When we connect the endpoints of the radii to meet at a point across the circle, we form the angle at the circumference, which we've labelled x. This theorem states that the angle at the center is twice the angle at the circumference, so we've labelled it 2x. This pattern is recognizable as a dart shape that includes the circle's center. However, by moving the point on the circumference, we see that it can also look like this, or even this. And if we move the radii to form a diameter, we get the same result as the angle in a semicircle. The angle at the center is a 180 degree straight line, and it's twice the angle at the circumference, which is 90 degrees. If we move the radii so the angle at the center is greater than 180 degrees, the relationship looks like this. In this case, remember that the angle at the center is this reflex angle, not the angle on the other side of the radii. So, given a problem like this where we need to find angle x, we recognize this pattern with the angle x at the center, formed by two radii, and a 75-degree angle connected to the ends of these radii. We can apply the angle relationship and state that angle x is twice the angle at the circumference. So 2 times 75, or 150 degrees. And in this example, where we need to find angle B, the same relationship can be used. But first, we have to calculate the reflex angle A at the center. And since we know that angles at a point add to 360 degrees, angle A equals 360 minus 110, or 250 degrees. And with this angle, we can now apply the angle at the center relationship. This 250-degree angle at the center is twice angle B at the circumference, so we just need to divide 250 by 2 to give angle B, which is 125 degrees. In this problem, we are given this 32-degree angle made between the radius OB and the chord BC. How can we calculate this angle BAC? First, we can identify this isosceles triangle made from two radii. Since the base angles of an isosceles triangle are equal, we know angle BCO is also 32 degrees. We can now work out the third angle in the triangle, as we know the angle sum is 180 degrees. So this angle equals 180 minus the two 32-degree angles, giving 116 degrees. Finally, we see that this 116-degree angle is the angle at the center and will be twice the required angle, BAC. So 116 divided by 2 gives angle BAC as 58 degrees. And we can summarize our working by giving the geometric reasons we used at each step in abbreviated form.